Hello and welcome to our video on sine and cosine graphs. Now the very first thing I'd like you to look at is filling in these tables. All you need to do is, and you should know at least up to here, you should have memorized those first bits. You'll need to put sine of 0 in and put your solution, which is 0. Sine of 30 degrees or pi over 6. 1/2. You need to do the same with cos. Make sure you keep going into the second line. You can pause your video now so you can get your work done before you have a look at the solution. So hopefully you have a table that looks something like this. You may have filled in your solutions with decimal approximations, and that would be fine for this example as well. You could have either. What I'd like to highlight for you are these main numbers that keep repeating. So if we look here, we've got a 0, and then sine goes to 1, then it goes back to 0. If we keep looking at sine, it goes to -1, and then it goes back to 0 again. Cos, so these are our main points. These are numbers that we know really well. Cos starts at a 1. Then it goes to 0. Then it goes to -1. Cos. Then it goes to 0. Then it goes back to 1 again. And hopefully while you were filling these in, you got a feel for it's a bit of a repeating pattern, and it will become clearer when I show you the graph that we're going to draw. But for now, if we take this section here, so from 1 to 0 for sine x, and you look at this first section of cos from 1 to 0, and you should have similar values. And if you keep going, so you look at this section on cos, 0 to -1, you will find it on sine somewhere. So sine is at 0 here, and it continues on to the next line, and it goes to -1 here. So that block from 0 to -1 for sine is identical to this block here for cos. If we kept going further than 360 degrees, we'd find that these patterns repeat themselves. And this type of a graph is called a periodic function. It means it keeps on going. So let's look at what these graphs actually look like. This one here, and I know the information is drawn with really little writing, but this is the equation of the graph. It's y equals sine x. And all I've done is taken these values up here. For x is 0, sine x is 0, so we start at the origin. Going up to when x is pi over 2, sine x is 1. When x is pi, sine x is back at 0 again. Then we go down to -1 and back to 0 again. From here on this side, the graph is just starting again and it's repeating. If we kept drawing the graph, it would just keep on going like a nice wave. Going back before into the negative x axis, it continues on as well. The graph of y equals cos x is similar, but what we've done is shifted it over a little bit. So we've taken it from here and moved this bit over. So our cos x graph starts at 1, and then it goes down to 0 at pi. See how this one, oh sorry, -1 at pi. This one was 0 at pi. then it goes up again and it gets to 2 pi and it reaches where it started again at positive 1. From here on, it's repeating itself and it's just going to keep on repeating in a wave. Same thing if we go down into the negative, it will just keep repeating in a wave like that. Let's look at some definitions of some of the terms that we need to know. So what I've got copied out here for you again is a graph of y equals sine x. Starts at the origin and moves up and down and finishes here before it starts repeating itself again. Finishes at 2 pi, which was 360 degrees. The mean position, or the axis of symmetry of the curve, so you can see around this line, the x-axis, which is y equals 0, it's symmetrical and it's equal. It goes up 1 and then it goes down 1. So the mean position, or axis of symmetry, is y equals 0. The maximum and minimum values of sine x are, well, the maximum, it goes up to 1. I'll put a positive in there to remind you, and it goes down to -1. The distance from the mean position, that was this axis here, up to the maximum or down to the minimum, will always be the same. And it has a special name, it's called the amplitude. If you've done waves in light waves or any kind of waveforms in physics, you might have come across the term amplitude before. And amplitude, I want to make a really big, I'm going to put it in red, big reminder to you here. It's just a distance. It's a length, how far the wave goes up. I'll put an A there for amplitude. It can't be negative. You could never say, oh, can you just drive -5 kilometers down the road? Amplitude is never ever negative because it's just a distance from here to here. Even if it's below the axis, it's still, whatever the distance is, it's 1. The distance is called the amplitude. The amplitude of y equals sine x. So this graph we've got here is 1. The sine curve repeats itself in cycles after an interval of 2 pi. So it's called a periodic function. The period, or the cycle length, of y equals sine x. So this is another word you need to know, period. Period is just one cycle before it starts repeating itself. So it stops at 2 pi. The period of this graph is 2 pi. It goes from 0 to 2 pi. That's how long one cycle is. You might like to have a look at these graphs yourself and pause the video, try and see if you can find the amplitude, the period, and write the range of each graph. Pause the video now. Okay, for the first one, we need to find the amplitude, which is how far up it is. This one has an amplitude of 1. I'll draw it in there in blue. The period is how far it goes until it repeats itself. This one goes from 0 to 2 pi, so the period is 2 pi. The range is the y value, so it goes from -1 up to +1. And this was just our sine x graph. Hang on, I'll finish writing this. This was our sine x graph that we have already looked at. Next one we're looking at, the amplitude. How tall is it? It goes up 2 for this one. The period until it repeats itself is still 2 pi. And the range is -2 to 2. Make sure you put your negative number first when you're doing your range. And it's inclusive because it actually does reach +2 and -2. Amplitude here is only 0.5. Period is 2 pi again. And the range is -0.5 2.5. I've forgotten to highlight the equation of the graphs. This was 1/2 sine x, so there's a half out the front. This one up here was 2 sine x, so make sure you keep track of which graph goes with which equation. Final one is 2 sine 2x. The amplitude is 2. Period for one cycle. This one finishes at pi. So the period is just pi, and the range is -2 to 2. Oh, 2 more on the next page. Amplitude for this one is 2. Period for one cycle, sine cycle, finishes here, so it's pi over 2. And the range is -2 to 2. Amplitude here is 2. Period is a bit harder to work out. You need to keep this graph going, or you could work out from here to here would be a whole cycle. However you work it out, you should get 4 pi for the period, and the range is -2 to 2. Let's highlight those equations. If you're looking at the equations, you might start to get a feel for what the different numbers in the different places do to the graph. Okay, what I'd like to look at now are some general graphs of trig functions. So I'll just put an extra heading here. General graphs or basic graphs. We know the base graph of y equals sine x looks like this, and it goes up to 1 and down to -1. It starts at 0 here. This is 2 pi for its period. The basic graph and all the things we talked about in these examples up here apply to cos as well, but it would just start up here and go down before it comes up again. So the base graph of y equals cos x looks like this one. Again, finishes at 2 pi and 1 and -1. The graph of y equals negative sine x, you might like to try it on your calculator, will just be flipped upside down. And negative cos x the general equation we're looking at for sine and cos graphs is y equals plus or minus a sine n bracket x plus h plus k. And hopefully you might start to look at this and see some things that make sense from some of the other graphs we've looked at doing. So the plus or minus will tell you if it's a positive or negative graph, which is actually what I've just drawn straight up here. So I might just extend the arrow, or the negative or the positive. The A in front of the sign is the amplitude. The N helps tell us the period, but we need to do a bit of thinking. Period is 2 pi over n, so whatever this term is here, 2 pi divided by that number will give you the period of the graph you're drawing. X stays in there. X plus h gives you the horizontal translation, just like all our other graphs. And k on the end gives us our vertical translation.